Um, so you guys started on condensation reactions, chapter 22. Be happy because this is your last real chapter of 4.2. Um, so I'm trying to see, don't you guys know what the formula for phenylacetone phenol or phenylacetone phenol is? Can anyone try to guess what it would be? Because so you want to draw out the mechanism in order to form. So the thing is, we don't have it yet. So what we start out with is just phenylacetone. So does anyone have any clue what the formula might be for that?
Oh, no, it's fine.
There's actually
There's another chair up there. Okay, so phenylacetone, let's break it down though, because it's good to know what the names are too, granted. So, but let's see if we can break this down. So phenyl, what's the phenyl? Yeah, it's a ring. And then what's acetone? CH3. And what else? And then phenyl. So it's basically just an acetone stuck on a phenyl. Okay. So what we want to do now is form the enol for it. But what's the key word in this sentence? Acid. Exactly. So we got to make sure that we're using acid in order to form. So, does anyone remember what exactly? Good question. Yeah, the high. So, what we always do, we're in an acid, you see a nice little oxygen carbonyl group, most likely that oxygen is the one coming in contact with hydrogen. We had an alcohol in there. No, we're giving up on that. For Lent, once in a okay, so we now have this. We want to form an enol. What's an enol? First off, let's probably not. Exactly. So it's an alcohol right here, and then we have an alkene right next to it. So how are we going to form it? What are we going to do? Exactly. So we have these alpha carbon hydrogens. This is acid, so we know that we probably have some H2O floating around in there. So the H2O is either going to take that one or that one. We'll say path A, path B. And then exactly what you're saying is that the electrons are going to jump down and then they're going to be pushed up into the oxygen. Okay, so this will be pathway A. And then with this one, we get our double bond right there. We have our OH group. And then we have our CH3 coming off. And then we also had pathway B, which will give us that. So do you see where these double bonds are? This is important. This is the basis of. Exactly. So it's going to be between the alpha carbon and the carbonyl carbon. It's going to form that double bond. So it's important to remember. Now, which one of these is going to be our matrix problem? Why the top, or why A? Yeah, so actually this double bond is conjugated with the entire ring. So it makes it more stable. So this is going to be our major product, but we're still going to get some of that. Great. So like I said, this is going to be the basis of everything in this chapter. Okay, so two different reactions. First reaction, our first step is adding aldehyde. So I don't remember what aldehyde does. You don't even have to show me a mechanism or anything. Just what is aldehyde? Okay, if it came in intact, what is going to be the final product of it? What is the whole point of aldehyde? What's it going to do? What did we just talk about one slide back? Formation of phenols. So what does aldehyde probably do? It forms an enol. So our first step right here, we form an enol. So what is this enol going to look like? Okay, so then we get a double bond between the alpha carbon and the carbonyl carbon. Okay, so this was our first step, and it's symmetrical if we did either side, so we don't really have to show two different things. Okay, so now though we're adding CH2CH. Actually, if I wasn't write this out, that wasn't that. Double bond. So what do you think is going to happen right here? Actually, you probably could have something like that happen. The conditions probably have to be. What did we just form? And what specifically on it? Double bond. Yeah, exactly. If you remember from, I don't remember what chapter it was, but it was when we did elimination, so, or the opposite of reverse direction. The double bond is actually going to come and attack that carbon to the R. Okay, so step 2 is then going to give us this OH, and then we have on the carbons 1, 2, 3, 3, and then our double bond was between our last two. Okay, so now though, does it just stay like this? Attack. Oh, you mean like in this double bond? Most likely that's not going to happen. It's probably not going to happen just because of how much of this that we use. If we had like 2 equivalents of that, then something like that could happen. But with this one, actually, what do we have floating around? A bromine, right? What does a bromine like to do? Exactly. So, what if we came and we took that hydrogen, and then that came down and formed our double bond? We're actually going to form. So that's going to be our final step. Because we have that bromine floating around. That bromine wants to extract a proton. Okay? So, actually this mechanism isn't fully complete. Because if we were to take off hydrogen here, we'd put a negative charge there. If we drop a pair of electrons, we still have this negative charge floating. So what would we do? Yeah, there need to be some sort of work out there. Something to extract another hydrogen, then putting that negative charge